Hello. Welcome everyone to this quickie where we have René Gröschke for his first time at JFocus talking about Gradle. Welcome.
Thank you. Yeah, we just have 50 minutes, so I have to do it fast. So no big introduction. Pardon me, I changed the title a little bit, named it Gradle Heading 4.0 instead of Gradle 3.0 and beyond. Because I think we are closer to 4.0 than we are to 3.0, so pardon me. And I'm actually not cover anything we did before 3.0, I think. So who am I? My name is René. I'm working for Gradle since 5 years now, live in Berlin. Yeah, and I have a Twitter and a GitHub and an email account. So what I try to cover in the next 50 minutes is I will talk a little bit about the Gradle momentum, so how we develop, and what you can expect. Then focus on the latest features. I split it up a bit, so I've prepared some demos, but I will first talk about these features I want to mention, and then at the end, let's see how it goes with the time, do some demos. Talk a little bit what we're currently working on. I haven't found the ASCII doctor for striking that through. I think we don't have time for that. Let's see. Yeah, demos, and yeah, I brought stickers with me. Yeah, so latest features, or my personal features, personal best features. So whose build is too fast? Really? What are you doing? Nothing? Sorry? Okay. So yeah, actually, I think one of the biggest the feature of a build tool is it has to be fast. So we consider performance as a feature, and well, actually, I skipped already some slides. So there's a management summary for those of you who are not engineers. Anybody? Okay, I can skip that, I think. So currently, there are 20 guys working full-time on Gradle core, so we have quite a momentum in development, and we have plenty of features we want to get out, and there are so many things not solved yet. So we released 3.0 in August last year, and yesterday we just released 3.4 RC2, which brought some cool features I'll talk about later. And average, we release every 4 to 6 weeks. Well, to be honest, make it 6 weeks. And so we have quite a fast pace, I would say. So that the important thing is to be compliant to earlier versions, so that's something we really keep in mind. And major releases like 3.0 or 4.0 don't have big bang features in it. Usually what they're just milestones or just releases, major releases where we can cut deprecations off and stuff like this. So usually we do it in an incremental way. So yeah, you already told me your builds are not fast enough. So yeah, we consider performance as a feature, and performance is, you can do whatever you want, somebody will complain that the build is too slow. And we saw that with Gradle obviously too. So what we changed, or what we did now, is we formed a dedicated performance team. So we have like 6 to 8 people who focus really on work that brings you performance. So what we achieved so far in the last couple of releases, we got plenty of stuff faster test execution, faster IDE integration, which is especially important if you are, for example, Android developer. Any Android developers here? Plenty. So there's this tight Gradle integration in the Android Studio, so it's important to be fast there. We worked on faster dependency resolution, and all the performance stuff we're doing is an ongoing effort, so we're running not out of things to solve here or to do. And as part of that performance burst, so to say, since Gradle 3.0, we enabled the Gradle daemon by default, which is a long-living background process that takes requests to run Gradle builds. And it really avoids costly JVM bootstrapping and benefits from warmed-up compilation. So especially if you use Gradle on the command line, that makes such a huge difference in user experience. And we will add more features to the daemon in the future, like moving up-to-date checks in the daemon, do preemptive checks and stuff like this. So you can expect more from the Gradle daemon. Who knows what that is? That little island there. There's a little island near St. Petersburg called Kotlin. So what we started with, I think already before 3.0 actually, we started working on a new Gradle scripting backend so that you can write your build scripts in Kotlin. Who never heard of Kotlin? Never? I thought not ever. Okay. So Kotlin in a management summary again. It's statically typed. 1.0 was released last year. What we really like about it, it's driven by pragmatism. It's similar to how the Groovy world works. And it's maintained by the JetBrains guys, the people behind IntelliJ and all the other nice IDEs. And we saw that there's a considerable uptake in Kotlin usage, especially in the Android world. And we really enjoyed the language. And we have some demand to change something in our build scripting. So the motivation for that is that, for example, the current DSL was not designed for performance or for tooling friendliness. The basics of the DSL are beyond 0.1, so it's never has really changed. Something we added more stuff, but the fundamentals are the same since then. And we could probably bring. There are spikes out there by Cedric, who's Gradle or Groovy developer and Gradle developer, who changed the DSL in a way that it's more friendly for tooling and performance in Groovy. But we decided to go with Kotlin. We paired with a Kotlin team on this, and that's an ongoing effort. And the idea is here to really get first level or first class IDE support. So I think we underestimated the need for good tooling in the last couple of years. I did plenty of consulting, and people asked for better tooling and say, hey, you can write it in a TextMate file. But that was not so convincing. Yeah, and you want to apply. So I'm a Java developer. I know that I can only code if I have code completion and stuff. So you want that in your build tool, right? Or for your build scripts too. And that's where we see the big value, that you have the full IDE support with documentation lookup, refactoring capabilities in your build scripts, so that you don't have the break between the way you develop your production code and the way you level you write your build script code. So that's what we're currently working on. Current state, you can write most of the stuff already in Kotlin. Your build scripts. Gradle 3.0 supports milestone 1.13. And with Gradle 4.0, which may be there in spring somewhere, we want to call that be feature complete or feature complete compared to what we have for Groovy. Yeah, next. Composite builds, that's quite a nice feature. So if you work in different teams and you have different jars you build and you depend on something else, which is not part of your build, so you have plenty of smaller builds, sometimes you want to compose them to test new changes, to test local changes in something you depend on. That's where you can use composite builds. So that allows you to build multiple individual projects as once. So you have two ways to do that. One is you can declare a settings file where you include them, or you can just do it on the command line. And that it really brings more convenience for teams that, or for companies that work in different teams, or that rely on closely on some third-party libraries they change. That's one good feature. I talked about performance, and no build is fast enough. What is the easiest way to make things faster is to do less, or it's not the easiest way, but the obvious way is the less you do, the faster you can be, also as a build tool. And what we added now in 3.4, which is about to be released hopefully next week, is we improved the compile avoidance. So far, so who's using Gradle at all? Very good. So you know the up-to-date check. So you have a task. A task has inputs and outputs, and if something or if both is the same, you mark the task as up to date and you skip executing it. So far, so good. What you have in the Java world is if you implement something you have a multi-project build with plenty of stuff, and you change something on the very core, all your dependent projects must be rebuilt, right? Because your class paths change for the further compilation steps and so on. So especially if you have huge multi-project builds, that adds a lot of overhead, especially for the guys working on the core. So we think we can do better and improve the way the compile avoidance work, or the up-to-date check in that case. So what we introduced in 3.4 is that we now detect application binary interface changes and only trigger the rebuild if the interface has changed. So if you change something in your implementation detail of an upstream dependency you have, you don't need to recompile your own code. You just need it at runtime, right? Because you don't change it. That improves dramatically the incremental build performance. Yeah, and I hope I have time to demo it later. Yeah. Talking about up-to-date checks. The Gradle up-to-date check at the moment works that if there is something from the last time that hasn't changed for this particular build on this particular machine, you rebuild. You don't need to rebuild, right? You mark that as up-to-date. But again, I think we can do better here. So why would you not like to have, if somebody else built your stuff, or if you built that stuff anytime before, on any other build, maybe on another branch or whatever, anywhere, so not just on your machine, but also on other machines, we want you to reuse the artifact, because like, let's say you're a company with 50 engineers, or make it 100, easier to do the math. And everybody comes in the morning, makes a clean checkout, and does a rebuild. 100 people build exactly the same artifact and waste the company's time and your time. So your coffee breaks might get smaller. So what we're currently working on is what we call a build cache to avoid that. And yeah, let's go to the demos. I start with the compile avoidance stuff. So I have a simple build here with three with 3 projects. And here you have that up-to-date check, right? You have core, where utils depends on, and you have app that depends on core and utils. So what I do now is, IntelliJ is not happy in the way I named my method here. So that is person lives in core. So both depend on that. So if I refactor that to do proper naming, follow naming conventions, what do I have to rebuild? Recompile. Actually everything, right? Because I changed the signature, and since the signature has changed, the API of core has changed, and the stuff that depends on it needs to be rebuilt. But what about, what about this place here, where I have birth date? I do the same thing. That's actually just the local variable. In earlier Gradle version, if you build now, you would again compile everything, right? Or not just Gradle, with every other build tool, I think. What you have now is Gradle detects that the API hasn't changed. Can I use 5 minutes more? The API has changed, so you compile the one project, but all the dependent projects you do not recompile. And you can imagine that saves you a lot of time. So okay, one last demo about that build cache. So what I have here is I have a Redpack app that serves as a HTTP caching backend, and what I can do now is, sorry, that thing is under development, so it's not really good documented. So if I do a clean build here, nothing, no surprises, apart from that the compile Java task is taken from cache. So it's not recompiled, it just, what it does is it hits the cache and saw that there's somebody built that stuff before, so I don't need to rebuild it. So, and if I run it again now, even with the clean, everything is from cache because I just built it and I moved it to the cache. At the moment that's running locally, you can see that here. But that's something that we want to, yeah, you can do that in a distributed way, obviously. Yeah, that's my 50 minutes. If you have any further questions, maybe outside we can have a chat. I'm happy to do so. As every company, we're looking for good engineers. If you're looking to work from home, international team, apply. Yeah, questions outside. Thanks.